Okay, this video is about methods of integration or the strategy of integration. And so there's no definite way to integrate. You just kind of have to play with each one and use some logic and some experience. So here's the first one. I got these from our textbook. That's why I labeled it 4. Here's I'll label it 1 for our purposes. The integration of sine cubed x over cosine of x dx. So one of the strategies or the things that they say is good, and it is good, is to try to simplify the integrand before you try to integrate it. So when I'm looking at this, I see I have at least a sine squared. So what I'm going to do is I'm going to change this numerator into the sine of x times the sine squared of x over the cosine of x. All right. Why does that help me? Well, this is going to help because of the Pythagorean identity. I can rewrite sine squared of x into 1 minus the cosine squared of x. And then I can get an integram with everything in terms of cosine except for one sine. And if I hold back that sine, that's helpful. Then I can use substitution. Let's see how this works out. This is 1 minus the cosine squared of x all over cosine of x dx. Okay, so this is equal to the integral of, if I distribute the sine to each of these, I can write this as the sine x minus sine x cosine squared x all over the cosine of x dx. All right, what does that give me? Gets worse before it gets better for sure. The sine of x over the cosine of x. Okay, I can integrate that using a substitution. Minus the integral. There's a lot of simplification that's going to take place here. The sine of x times the cosine squared of x over the cosine of x dx. This one, I can divide one of these cosines into one of these. So really, I have the integral of the sine x over the cosine of x dx minus the integral of sine x dx. Okay, where can I go from here? Well, this I can use oops, I left off, I have one cosine. I can use substitution in both of these cases. If you let u equal to the cosine of x, then du is going to equal to negative sine of x dx. We can rewrite the first integral as, if I say negative du, what did that give me? Sine of x dx, 1 over cosine of x, or 1 over u. Okay, minus. Here I can also let u be cosine. That will be fine. Then du is negative sine x. That's what I have there, negative sine x dx. So that is my du. So this is just going to be the integral of u du. And this is plus, because when I rewrote it, this du was minus sine x. That's what I have there, and I need that. So I need to say plus du times u. All right, then I can just integrate this. This is negative natural log of u plus 1/2 u squared plus a constant. This is negative natural log of, what was u? Cosine of x plus 1/2 cosine squared of x plus a constant. You can rewrite this. This is what we've developed before. You might have recognized this as tangent, and if you've memorized that the integral of tangent is the natural log of secant, you can rewrite this as the cosine to the negative 1, which is 1 over cosine. The natural log of secant is another way to write this result. All right, so that is one. Let's look at another one, see what we could do here. What if they give us something like this one? integrate from 0 to pi over 2 t times the sine of t times the cosine of t dt. What should we do here? You might think about rewriting it first, but really when I see this t, this polynomial, that's very simple here, and I know I can integrate sine t, cosine t, then I'm going to try by parts. So if I do by parts, I'm going to let u equal to t. I'm going to let dv equal to the sine of t times the cosine of t dt. And in order to integrate this, let's see, I'm going to let u be either one. I'm going to let u be the sine of t. Then du is the cosine of t dt. And so what I have here, just to integrate this, the integral of sine t cosine t would be u du, which is going to be 1/2 u squared. So v is going to be 1/2 sine squared of t. All right, and then du is just dt. Okay, so if I'm integrating by parts, at the very end I'll put the limits back on. So this integrand is equal to uv, or t, times 1/2 sine squared of t minus the integral of v, 1/2 sine squared of t du, which is dt. Okay, so then I just have to integrate this, which I can, but when I have a sine squared or a cosine squared, it's good to rewrite it. I'm going to rewrite sine squared of t as 1 minus the cosine of 2t. I'm going to use this double angle identity right there. All right, so let's do that. We have to integrate this guy. So this is minus the integral of 1/2 times sine squared of t is going to be, oh, actually it's 1/2 this. This is 1/2 this. Times 1/2 times 1 minus the cosine of 2t. Okay, let's get rid of some of this constants. This is going to be minus 1/4 the integral of 1 minus the cosine of 2t dt. And this is still here. I haven't forgotten about him. All right, so this is, let's integrate 1. That's just going to be t. So this is minus 1/4 times a t. Let's integrate cosine of 2t. That's the integral of cosine is sine. We have to adjust for that too. So this is minus 1/2 the sine of 2t. All right. And now let's bring this other part down. This is 1/2 t sine squared of t minus 1/4 t plus 1/8 the sine of 2t. And now we can evaluate this guy from 0 to pi over 2. And when we do that, I'm just making sure I like what I have there. Yep, I like what I have there. When we substitute in pi over 2, we have 1/2 times pi over 2 times the sine squared of pi over 2. The sine of pi over 2 is 1, so we have 1 squared. Okay, minus 1/4 times pi over 2 plus 1/8 times the sine of 2 times pi over 2 is the sine of pi, which is a 0. All right. And then we have minus. If I substitute in 0 here, I get 1/2 times 0. This is a big 0. Minus 1/4 times 0. This is a big 0. The sine of 0 is 0. So all of those terms ended up being 0. So what's left is pi over 4 minus pi over 8. You can get a common denominator of 8. That's 2 pi over 8 minus 1 pi over 8 is going to be pi over 8. All right, let me choose one more example for this video, and then the rest is probably just, you guys will practicing. And so here is one that we're going to do, the third one. Let's integrate 2x minus 3 all over x cubed plus 3x dx. When I see a rational function like this, and I can factor out a x, I'm thinking partial fractions is what I'm thinking. I'll rewrite this first. So let me try to do that. If I try to do that, I have 2x minus 3 over, I'm going to pull out an x. X times x squared plus 3 is equivalent to something over x plus something over x squared plus 3. Okay, this is linear, so it gets a constant. This is quadratic, so this gets a bx plus a c. All right. Then I'm going to kill my denominator by multiplying both sides by the lowest common denominator. And when I do that, on the left I get 2x minus 3. And when I multiply a over x times x squared minus 3, I get a times x squared plus 3. Bx plus c over x squared plus 3 ends up being bx plus c times x. And so now 2x minus 3 is ax squared plus 3a. Bx squared plus cx. I'm going to group my x squareds together. This is a plus b. Cx, 3a. I can put a placeholder here. Since I don't have an x squared, that's going to be a coefficient of 0 plus 2x minus 3. Let's equate coefficients. 0 is equal to a plus b. 2 is equal to c. C is equal to 2. Negative 3 is equal to 3a. And we get 3a is equal to negative 3. So we can solve. Oh, I'm dividing by either the wrong thing. I can solve for a by dividing both sides by 3. A is negative 1. If I know a is negative 1, then I can solve for b. I get b is 1. I can rewrite my integral into, I can say the integral of 2x minus 3 over x cubed plus 3x dx is equivalent to the integral of a over x, or negative 1 over x, plus 1x plus 2 over x squared plus 3. Okay, so all I have done so far is rewrite the given integral. Now I'm going to try to integrate this. So what I'm going to do is I'm going to rewrite it further. I'm going to say this is the integral of negative 1 over x dx. I'm going to split it up, plus the integral of, I'm going to split this into two fractions, x over x squared plus 3 dx, plus the integral of 2 over x squared plus 3 dx. Okay, the first one easily integrates into negative the natural log of x. Okay, the second one, I can integrate this by using u substitution. Let u be x squared plus 3. Du will be 2x dx. So 1/2 du is x dx. So this will integrate. I get the x dx simply by writing down 1/2 du. Okay. And then what's left is 1 over x squared plus 3, or 1 over u. So this is going to be 1/2 the natural log of u, or 1/2 the natural log of x squared plus 3. Okay, so that's the second one. We have this plus this. Okay, this third one, I'm going to pull out the 2. And then I have x squared plus 3. And if I think of this as the integral of 1 over x squared plus the square root of 3 squared, I see that this is x squared plus a squared, and I recognize this as the tangent inverse. This is tangent inverse of x over a, 1 over a times that. So this will integrate into, the 2 is out there, 1 over a would be 2 over square root of 3 is what my a is. The tangent inverse of x over the square root of 3 plus a constant. So negative natural log of x plus 1/2 natural log of x squared plus 3 plus 2 over the square root of 3 tangent inverse of x over the square root of 3 plus a constant is what I get for that one. Okay, that's just a few examples of how you might have to think through different integrals that you're given. But practice is what makes things better.